Hello, everybody, and welcome to our webinar, Skyline's webinar on Skyline Globe Server version 7.3, new releases. My name is Eilon Sirotkin. I will be taking you today through the Skyline Globe Server new features, as well as TerraXplore for Web, which is part of TerraXplore Server or Skyline Globe Server. Today so first of all, I want to welcome everybody from all over the world to this session. This session is going to take about 1 hour, may run a little longer or shorter, depending on questions. We will have time at the end for questions, but using the webinar system, you can log questions at any time you have. We have our panelists sitting with us as well. We have Arik Katz, and we will be monitoring your questions during the session, as well as at the end. And if anything is relevant at the moment of the relevant questions, we will stop and answer that. Or we may, depending on time, go back to the questions at the end and try to answer as many of them as we can, or take them offline with each of you. I also welcome you tomorrow to another webinar we have on TerraXplore Desktop version 7.3 and its new releases. There's a lot of interactions, as we will see in the today and tomorrow, regarding how TerraXplore is used as the publisher, the building tool for the scene, for anything you want to share with your audience. And these two webinars complement each other, and this is why the versions, also their release, is one next to the other. So this is what we have in plan for today. So Skyline Globe Server, most of you know what it is, the place of Skyline Globe in the Skyline suite of products, the Skyline Globe suite. So we have the sources and the building, and Skyline Globe Server is in charge of the cloud services. This is where we'll be focusing on in the first part of the presentation. Later, we will talk about some of the clients, or specifically on TerraXplore for Web. So the way Skyline Globe is architectured within the suite is that we have TerraXplore Pro as the publishing tool. So this is where you would take your meshes and your terrain and your GIS files, GIS databases, and so on, and decide and define how you want to view it, what functionality should it have, what messages, what classifications, and so on. And then when you're done with defining the scene and the view, you actually upload this into Skyline Globe Server. So Skyline Globe Server is built from various services, one of which is the upload, and this is actually the link, the channel from which you can publish your TerraXplore Pro project into the Skyline Globe Server. And it is designed for the cloud. So you no longer have access to the actual Skyline Globe server, like to RDP and so on. All the communication is done through the Skyline Globe Server Manager, and the publishing components where TerraXplore and actually other clients like TerraBuilder can publish into Skyline Globe Server. And they publish data into its storage. We'll talk about the different types of data it shares, like project, terrain, mesh, features, maps, and point cloud. And that will be on the next, on a more detailed format level slide on the next one. And Skyline Globe Server also manages the users. There's a full user system, including being able to connect to other authentication systems. There's a catalog that catalogs all the data that is shared and hosted on the Skyline Globe Server. It allows reports and admins and so on. So this is what we're going to talk about, Skyline Globe Server. And then the end result of the Skyline Globe is actually to stream data out to different clients, being the TerraXplore family of clients, whether the desktop, web, or mobile, and also other clients. And we will see some very nice examples today on how to share to different OGC clients and other clients like Esri, Cesium, QGIS, and actually we're going to talk today about Unreal Engine as well. As far as the formats that go, so TerraXplore really can take a vast amount and types of formats. being features like the industry standards, most industry standards like shapefile, SQLite, GeoPackage, KML, and so on. Different types of imagery and elevation data. These are raster data, as well as terrains, which are compound terrains from imagery and elevation built using TerraBuilder, including Direct Connect, which is one of the ScanGlobe features that allows you to connect on the fly many types of or many a large number of areas to create together a seamless terrain. We have the 3D mesh, which is the focus in the last few years, which streams texture meshes as 3D MLs, 3D tiles, OSGB. These are all the inputs that are created by different systems, including Skyline's photo mesh that does the full photogrammetry solution from photos all the way to your textured mesh, as well as other products like orthophoto, DTM, DSM, LAS, point cloud data, and so on. We can also take point cloud data from different sensors like LAS and E57 and convert them into our proprietary optimized multi-resolution CPT format and different beam data. So as we said, we take all this into Terra Explorer and then we push it into ScanGlobe server. So Terra Explorer does all the optimizations and the preparations that are needed to take any type of these Terra Explorer supported formats and put them into a format that is efficient for streaming. So there's a client-side optimization, and then the Terra Explorer itself pushes the data into Skyline Globe server where we focus today. So there are different uploaded scan formats like the MPT for the imagery, and there's the different formats for feature layers. So you can also put feature layers and data directly on the server on the disks over there. Like if you have an automatic system that publishes data onto a disk, ScanGlobe server can automatically scan folders on the server side and add them as published layers. It also have the projects, the Fly projects, which are created by Terra Explorer, then eventually converted to the streaming protocols that we will talk about. So on the internals, there's 3DML for the mesh layer and CPT for the point cloud. Then we have the streaming protocols, which is how Skyline Globe server actually serves all this information, whether as MPT or as WMS and WMTS for other OGC clients, as WFS and WFST. T stands for transactional, so you can actually make edits from the client side and the server will store this information in the original data source. We have the mesh, which Terra Explorer will consume it as 3DML and soon Open 3DML, but also it's exposed as 3D tiles, so to be consumed, for example, by Cesium clients or Unreal Engine, and also I3S, SLPK to be consumed by different Esri clients, and we'll cover that. In a similar way, Terra Explorer will read the internal CPT format, the optimized point cloud format, but that also can be shared into Cesium and Terra Explorer for web as 3D tiles. These would be 3D tiles of B3DM data, batch 3D model, and this would be PNTS for points data. And of course, there's the project where that combines together all the layers and locations and presentations and so on. And this is sent out to the different clients as desktop projects, web, and mobile projects. ScanGlobe server on the server side can also read data from different databases like Oracle, PostgreSQL, Microsoft SQL, ArcSD, etc. And then we have, once everything is put into Skyline Globe server, the data is streamed out into the clients. So we said the Skyline clients that we described, a big amount of the Esri family of products, the Cesium clients, QGIS or other OGC formats. And this is where we go to the actual features that are new and updated in Skyline Globe server version 7.3. One of the major changes we have done is to add support for MySQL, PostgreSQL management database. This means that up until now, Skyline Globe server management database that stores all the layers, metadata, and all the users metadata, and all the management level databases, as well as the statistics and reports and so on, they were stored on an SQLite database file. This is a file base. It's not a full database or an enterprise database, which the big advantage of that is that it's very easy to set up. You just go next, through the Skyline Globe server installation, and you have a database going. You don't need to have an IT person configure SQL for you. But when we work in big installation, and Skyline Globe server has a built-in functionality to work as a cluster, so you have multiple nodes, multiple computers. Normally in these days, these would be instances in a cloud platform, like we host our Skyline Cloud on AWS. So multiple instances are nodes within a Skyline Globe cluster. So the user connects to a single Skyline Globe, but actually it's being load balanced to multiple instances based on the need. So when we go to such enterprise level implementations of Skyline Globe server, what we actually see is that there's a growing demand from the database, and it's being used by many computers at the same time. And this is why we want an enterprise level database like MySQL. And it allows, for example, higher number of transactions than the SQLite, which after a few instances that connect to it may have some shortcoming on that. It always give a greater reliability. Being an enterprise server, you can back it up, you can cluster it, and you can do whatever IT database architecture that you want to put in place. These databases can also be managed databases, like an AWS Aurora, which is a shared MySQL or PostgreSQL database. So this is, again, how we host our services, Skyline Cloud. We have an AWS Aurora, and this is where we share the database, and this is how we can have multiple instances of Skyline Globe servers stream and share the data. The SQLite database is still there, still supported. So when somebody wants just a simple server on a company server or even on your laptop, the SQLite simple option, no enterprise database option is still there. This is a major change, allowing much greater reliability and functionality. The next thing we have added is the sites management page. Now, we already had sites in previous versions of Skyline Globe server. Sites are compound subsites of Skyline Globe server. So you can have your Skyline Globe server and then subset it into different groups, different areas, which are actually isolated instances of the Skyline Globe in a way that I can have, for example, in a city or a community, I can have a Skyline Globe server and then have different sites for engineering, for public facing, for education, and all these would be a subsite, and the users connecting to them will experience them as a single isolated Skyline Globe server. So we have made updates to the sites page. Let's have a look at that. So this is the sites page, and I have a new page and all the sites that are hosted on my Skyline Globe server, like QA, like GIS, like test sites. And then I can switch over, select one of those sites, manage this site, and then I will have the management only for that site. So what we do, for example, again on our hosting, is that we have a single Skyline Globe server, and then when somebody purchases an account on Skyline Cloud, they would get a subsite. And within that subsite, their administrators can connect to this page, not this one, which is the global administrator, but actually a local administrator for each of the site, and see the layers that are only on that site and the users that are only on that site. So we have really made that more robust and more easy to manage different subsites within the same Skyline Globe server. On formats, so we have made great progress in how we serve out 3D tiles database. So what we saw before is that the Skyline Globe server actually hosts the data internally as a 3DML format. So this is the most optimized format. It shares or stores the textured meshes in a very efficient manner, but it then exports it or exposes it as different formats, for example, 3D tiles or SLPK. And that's very nice that you have just one database on the server side. You don't need to duplicate those data sets, but when they are exposed as 3D tiles or as I3S, they're actually being converted on the fly with some caching mechanism. So the internal 3D MLs are, for example, shared out as 3D tiles to Cesium clients, to Unreal Engine, and so on. So what we have is we allowed better mesh styling for example, BIM and CAD models. And we actually use the 3D mesh and attributes are stored and shared with a batch table, which is a 3D tiles concept that actually adds an annotation associated with each of the features, each of the meshes in the 3D tiles. So you have a 3D ML of a BIM, and it actually carries attribute information. When it's being shared out to Cesium, or actually TerraExplore for Web, which is also based on Cesium, you can extract and query, and we will demonstrate how you can query and get the attribute information of the information stored in the BIM data. In a similar way, you can use that to do styling, for example, color based on attribute values, and also query the submodels based on attribute values. A similar thing is done on the 3D tiles for point cloud styling. So like we said before, the point cloud data, which is originally LAS or E57 that is received in TerraExplore, is being optimized and processed into a CPT, which is stored on the server side, and then exposed out as either CPT to TerraExplore clients or 3D tiles. So these 3D tiles, actually 3D tile is a carrier format. It can host or share different types of datas. In this case of the BIM or of the textured mesh, it's B3DM, batch 3D model. Or in the case of point cloud, it actually carries parts of a PNTS database, which is point cloud information. So this point cloud information, your LASes and E57 actually had attribute data, or scalars as they're normally referred to in the point cloud area. So these, each point in the PNTS database actually has a batch table as well, or there's a batch table associating the annotation information for each point, and you can query that from within the end client, because the attribute information, the scalar information, is streamed out as part of the 3D tiles format in the batch table. So we can do different styling based like point cloud and color, and we will see how in the example later on TerraExplore, we'll see how point cloud data is being colored based on the number of returns of that is represented in the attribute data of the CPT. On the 3D tiles for B3DM, the meshes, textured meshes, we've improved and updated to internal format of GLTF. That's actually the carrier of a textured mesh, so GLTF 2.0, and also allowed Draco compression. This is something that can be changed actually on a global level. If you look at your settings, there's a setting here, both for the format of the 3D tiles, to support older versions or older clients. And also you can, as a global definition, define whether you want to use Draco compression in your 3D tiles that are exported out or streamed out from Skyline Globe server. We support I3S and SLPK. So again, the 3DML is the database stored on the server side, but then different Esri clients, and there's a whole list of them, and they're actually developed differently. So each of them behaves slightly differently. There's a whole generation or family of different ESRI clients, and they can request and receive I3S databases. We'll talk about it a bit more in one of the next slides, but it's being converted on the fly to I3S SLPK 1.7. Now, the thing is, not all clients, Esri clients, read 1.7, and this is why there is a sort of negotiation when the Esri client connects to Skyline Globe server, which is actually serves as a portal for the Esri client. So when an Esri client connects to an Esri server, it shows as a portal, which lists all the databases under it. In a similar way, Skyline Globe server mimics that portal, so you can connect from the client to Skyline Globe server. It appears as an Esri portal, And then based on the functionality of the clients, it may be an older client or a simple client, and it still only supports 1.5. So ScanGlobe Server will take the 3DML and expose it as 1.5, reproject on the fly or convert on the fly. And if it's a new version or a higher level product, it will receive request and receive 1.7 SLPK. And there is some preparation done for that. When you publish the project from Terra Explorer, we'll take the 3DML and make it I3S ready. Another topic of accessibility. So ScanGlobe Server can host databases, data sets, and serve them as public layers, which means anybody can read them from Terra Explorer or from different, based on the protocol. So for example, it's WMS layers or WFS layers, and all the layers that are public can be accessed with no problem. But sometimes we want to protect our data and share it only with specific audiences. And in this case, what we do is we add restrictions to allow only certain users or groups or sites to be able to connect to those databases. And that requires a login with a username or password, sometimes even a more complex one, like you can connect the authentication into your organization, Active Directory, or identity server. But in any case, you need some kind of an authentication. And that requires that authentication, normally a username and password. And that doesn't always work. For example, there's some clients that do not have even the GUI to allow typing in that username and password. And this is why what we do is we added an authentication option, an additional authentication option that instead of, or in addition to the username and password, allows you to define an access token, and that will allow viewer access using this token. So this token will be concatenated or put as part of the access URL, and that will give the user who has a URL with this access token access to all the layers that this viewer user is allowed to access. So I create a viewer user. You see there's a role for viewer, and then I can generate a token and give it to anybody without them needing to know a username and password. This is also something that I can share with the public and know that only somebody who has this URL would be able to connect to that layer or to any layer that this viewer test viewer has access to. So again, or more on the enhanced support for Esri clients, using this negotiation and the mimicking of an Esri portal, when you connect from an Esri client, you can type in the username or password or the token, and then get access to non-public layers that are only allowed to be viewed by that user. So based on the authorization level. For all Esri clients, you can use the token or the login also for the 1.7. And we encourage you to go into our knowledge base, type in ESRI clients, and see articles on how you can connect to each of those clients, those Esri clients, and use them to read data. So that's one of the key points of ScanGlobe Server, that you store one database and you consume it from any or many different clients, being Terra Explorer clients, Cesium clients, OGC clients, Esri clients, and you have one server that fits all needs, whether it's the public that only wants Terra Explorer for web in the browser, or your analyst or your architect that are more on the professional level and use professional tools and need professional functionalities. On the accessibility, still we have compatibility with cross-site cookies. That's a security generation that is put out by the different web viewers, by Chrome and Firefox and all the modern viewers. And this allows, it's called same-site cookie. Cookies, ScanGlobe Server supports that. It allows you to connect to different ScanGlobe servers in different tabs of your browser and to read data. For example, in this presentation, some of the data I will show you will come from our development server over here, and some will be coming from our cloud server, and both or all would be consumed and authenticated by a single client that can read from multiple servers with multiple authentication levels. So it's compatible with Chrome and other viewers. Another thing is sometimes you want, we said that there's a single Sky and Globe server and can support many clients. It could be a vanilla Cesium, just your out-of-the-box Cesium. It can be TerraExplorer for Web, which, as said, is Cesium on steroids. So it has all the Cesium functionalities and then many more that we have added. But if you still have your legacy or your internally built Cesium implementation, you can read data from Sky and Globe server, including the authentication levels, and that is done by we provide a JS file called sgprovider.js. You add it to your Cesium implementation just as a reference, and then you can read, query different types of data from Sky and Globe server directly into your Cesium application, including imagery, elevation, 3D meshes, and leverage applications you may have already developed or have users that have such implementations be able to connect to that. So that's an extension to your implementation of Cesium. And then for the last Sky and Globe server new functionality, so Sky and Globe server, as said, supports or streams out the 3DML data as 3D tiles, and it works for many clients. Recently, there was a development and an open source development for Cesium for Unreal, which allows you to read 3D tiles data in Unreal Engine, very nice, beautiful and appealing gaming engine. And what we did is we did a number of customizations that allows you to connect from the Unreal Engine to a 3D tiles database coming from Sky and Globe server, and we will show you how that is built. So you install the Cesium for Unreal add-ons on your Unreal Engine implementation. It comes with a number of samples. Then you have the world, and you can add, you see a blank 3D tiles. All you need to do here is put the URL of the tile set that is coming from Sky and Globe server. We then georeference the scene to this area because the Unreal Engine is usually something localized and not within a globe or a world. So this sets your engine or your geographic position to the center of the geographic area. We can change the 3D tiles. For example, we change its altitude to fit the terrain that is there. You can control, for example, the camera speed when you navigate the scene. Now, this is still in the editor. This is how I build my game. I build my level. And so I add components to it, one of which is the 3D tiles coming from the Sky and Globe server. And then I can start playing in Unreal Engine. For example, I can add a component that will mimic or that will do a vehicle that is traveling through the scene. I will position it somewhere on the scene. That would be its start position. And then I should be ready to just play. So you go over, you set the this vehicle to be controlled by the player 0, and then you go ahead and start the game. Now we see the game view, essentially, not the edit view, and we can go ahead and navigate inside the mesh and use all the lighting and all the basically everything that Unreal Engine allows you to do and create appealing presentations based on the same data that is already stored on your Sky and Globe server and serves your different applications, your TerraExplorer applications, your Cesium application, and now also Unreal Engine. So this is very exciting for us. This first half hour or so was about the Sky and Globe server. Now, Sky and Globe server also packages inside it essentially another product, which is the TerraExplorer for Web. TerraExplorer for Web is our plugin free viewer that reads all the data from Sky and Globe server and presents it in the viewer in an interactive way into the user's browser. So if we take the same architecture, that's our powerful web-based 3D GIS viewer. And so after we did the cloud services part, this is where what we're covering right now, the web side of TerraExplore for Web. And we will go over the new features in version 7.3 for TerraExplore for Web. There's been a major work done on improving navigation performance, frame rate, especially for medium low-end machines. We'll talk about the auto mechanism in a second. It allows you to load really complex projects with many different or many features within a layer, with massive 3D mesh layers of very big sizes. It's really easy for the system to handle that. Even include a few different feature layers in the same scene and really create your unified view or your common operational picture inside a browser in a good frame rate and a good user experience. There's been optimizations, and this is something you just experience as the system being more fluent and the frame rates being nicer. So we did an improvement for the text labels. So you want many labels of your rows, of your points of interest in the scene. And there's actually a mechanism for an auto performance and quality. So in the past, when we look at TerraExplore for Web, we'll go over it in more details. There's a settings here, and there's a parameter for quality. So in the past, we had high, medium, low. And for different computers, you would set that so it would still work with low-end computers by reducing the number of features in the scene and reducing the number of polygons and simplifying the shadow and so on. So these were the high, medium, low, but now we have the auto mode. And this auto mode actually ensures optimal performance and quality balance. So it will gauge dynamically. So not only once when you start, but as you progress through the navigating into an area which is more dense in features, it will automatically adjust all the time and will change dynamically between those modes based on the performance of your computer and the complexity of the scene. Same goes for shadow quality. It will change it as you go into different areas. And as you zoom closer to the area, it will present a more accurate shadow. And as you zoom out and look at an entire city, it will do the calculation in a way that will still allow your computer to perform nicely and to the scene to be dynamic. And that allows you to maintain good user experience, which is mainly frame rate, but not only. We have created a new type of classification in both TerraExplore that will be discussed in the TerraExplore new features webinar, and also in TerraExplore for Web, where in the past, or what we want to do is we want to classify parts of the mesh, but not only mesh, based on feature layers. So based on features of buildings and based on features of cadastral data, and for example, do colorization as we see in the photos here. So based on the type of floor, of type of building, to apply different colorization to it, or allow clicking, what we used to call a geospatially enabled mesh, where the mesh actually is linked to GIS information, and you can click on a building and get the attribute information for it. So all these are what we call classification, allowing geospatial functionality within what was a 3DML but is now a scene. So anything in the scene, including areas of the terrain and point cloud information and so on. In the past, what was done, we had a product which was called City Builder. It's now actually part of the underlying components of TerraExplore. So City Builder used to take your mesh and your feature layer, bake them together into a 3DML that had all the GIS information. And that was very good and optimized, but that was baked. So even if one building changes, you'd have to redo the 3D ML with the new GIS information. And we have moved away from that. We still support for backward compatibility, but we are now doing dynamic classification, which means the feature layer and the mesh are no longer part of the same database, but they are independent, and regardless, the feature layer will classify the mesh. And that allows you, so I have just a mesh and I have a feature layer, and then I can add other feature layers to the scene, or I can update the feature layer, and that update one will still classify the mesh or the point cloud. And that gives you one-to-many or many-to-one kind of functionalities. So you can, on one hand, have very big mesh of an entire city, and then a feature layer for each part of the city. So you just load the 5 or 6 or 10 feature layers for each part of the city, and they together classify the same mesh or the same point cloud data set. On the other hand, you can have a many-to-one. So for example, you can have the same city, and then you can classify it once with the building information, and then turn that layer off, and turn on the layer that classifies it by cadastral information. So with this isolation and separation between the two, the attribute information, the classification information is no longer baked into the 3D ML, and you can dynamically classify any mesh point cloud part of the scene with any live, real-time, or updated feature layer. You can then apply the classification using different types. I will show you that, whether it's a polygon or a volume, which is a box like we see here, or using actually colorization of it. So we will color everything. You see the green box over here, which is the actual polygon, but we have a new functionality that will only color parts of the mesh that intersect that original polygon. And that creates a much nicer and visually appealing and functional kind of display. And if it doesn't fit exactly, you can apply a buffer to it. I will demonstrate it in another slide more. More on the types of feature layers and improvements, we have complex geometries. So in the past, even if your GIS information had multi-polygons, lines, or points, that's one feature that is built from multiple lines or multiple features. And now we support the multi-lines and multi-points. So if you have a road which is segmented, and for each of it, there's a different polyline, but it's still part of the same feature, we will now load all parts of the roads or all part of the points and so on. We allow a query filter over here. So you can say I have a feature layer that has a lot of information, but I only want to load the roads of type highway. And that's done as a filter. And even though the layer has all the information, only the queried or the features that match the query will be added to the scene. More is the feature layer styling. So as we said before, you do most of the styling in Terra Explorer Pro. You define exactly how your layer is going to be, and you apply the attribute-based coloring, for example, or point size in the point cloud data. And now we support more of the very rich set of styling that Terra Explorer Pro offers. Many more of those are now supported in Terra Explorer for Web. And in fact, there's now a new or improved property sheet in Terra Explorer for Web, but I will show you how I open for each of the feature layers, the property sheet, and I can actually change some of those styling that were done in Terra Explorer Desktop prior to publishing. I can now change that on the Terra Explorer for Web itself, and it's even saved in the session. So next time I refresh my project, changes that I did on my client side will be saved there. Not saved on the server, but on my client side, I can change the original styling that was done by Terra Explorer Pro and apply them in Terra Explorer for Web. And that includes, for example, field expressions like field by attributes, extend to ground, and so on. So let's look at some of that. What we see here is, for example, the city of Tel Aviv. We have a mesh underlying, and we have a roads layer over here. That's this roads layer. Okay, and it is classified according to the type of the road. So when I look here at the property sheet of the layer, this is the new property sheet, I can see that the color is actually not this black one, but the styling that was defined in TerraExport Desktop when I configured and published my scene. So this would be the roads layer. Another layer that I have here is the 2D polygons over here. So we start with a simple representation of it as just simple polygons, but with the feature layer, and of course, by the way, I can access the full attribute table, and I can perform queries on it, and I can see the attribute information and even edit the attribute information if it's a WFST transactional layer. So all this is here. This is not a new functionality, but a very powerful one. But now I have for the feature layer property sheet, and then I can define the style regardless of what was defined. Sorry, I want to load this layer, the building 2D. And now, in addition to the styling that was defined in TerraExplorer before publishing, I can say, for example, instead of polygon representation, I want a 3D polygon representation, and I'm going to give it a height of, say, -20, and apply it. And then it gives me a different styling for the layer. So I changed the height. At any point, I can restore to the project settings, and that will take me back to the styling that was defined by TerraExport. So let's see some of the other options that I can do here. We have added an extend to ground functionality, which will just take each polygon and extend it all the way to the ground. That's a nice feature over here. Go back to the original setting. Another thing I can do is I can still use the polygon, but I will now show it as a 3D polygon. These are the styling options that we selected. Now, to define the 3D polygon, I need to extrude it from the original polygon, which is the feature database. I can extrude it, for example, let's say 20 meters up and 20 meters down, and apply it. And this will create these types of polygons. So the original polygon was somewhere in the center, and now I extruded it up and down, in this case with a value, but this can also be done with an attribute value. So based on an attribute value of each of them to extrude accordingly. And now I can also do colorize objects. So colorize object, as we said before, will color only the intersecting parts of the mesh with the polygon. So the polygon was floating somewhere above, and the extrusion only affected this portion of the building. And in this case, I can go ahead and, for example, extrude down by 100. Let's let it load for a second. Okay, and now it's extruded all the way down. Another thing that we see here is that sometimes your feature data doesn't fully match your mesh data. For example, like here, so I can go ahead and add a buffer and see how I do all this on the client side in TerraExplorer for Web. And when the feature streams in, okay, it now has a bigger buffer around the area. In a similar way, I can do a query. So I have the highlight over here, and I can click and get the feature information. This can be done either from the layer or actually from the analysis query and get information on the layer. And another thing we like to do is we sometimes set the opacity to a low number, like 1 or 2%. So there's really no colorization, but still, when I click on the feature, I get the opacity, I get the feature information of it. Let's look some more into another project where I also have a feature layer that describes the floors. And you can see I defined a click operation where the attribute value for each of those floors would be returned, and I can access it. And this is done again, there's a layer here, and there's, you see this building levels layer, and I can see exactly how it is defined over here in the properties and control or access the floor information, the message information, change the colorization. You can see, for example, in here, the buffering is defined by an attribute value. So I know for each building, based on its height, how much of a extrusion to make so it covers the full building. So this is a bit about those kind of functionalities. I will turn this one off and continue to other features and then go back to TerraExplore for Web. So we did a modify terrain and mesh feature that is available in TerraExplore for a long time, and you could create that modification in TerraExplore and then publish it to TerraExplore for Web. But now TerraExplore for Web itself allows you to do it. I will go to an area I created over here, and you can see there is some construction going on here or something in an old building, and I want to place a new building here. I will simply go to the layers, do a modify terrain, select the area that I want to flatten, okay? Change it to the layer I'm working on, and what we will see after a short refresh is that this layer has been flattened. This is the modified terrain now also in TerraExplore for Web. Hold on terrain, similar functionalities we know from TerraExplore Desktop. You can now do it in TerraExplore for Web. Also, if you publish, but also create it live in TerraExplore for Web. So let's go to an area somewhere here. Look at some of the feature layer information like this. And now I can go ahead and create hold on terrain. And now what you see is that based on how this feature layer, unlike the presentation when we see it over here, it depends on the styling of the roads layer. So if I now go to the roads layer, and it's very nice that I can change its styling, and I change it to, instead of being on terrain where we cut the terrain and then it drops, I can change it, for example, to relative altitude like this. And then I see the hole like this. Or I can even do it absolute. And in this case, since the layer is actually underneath the ground, I can see sort of the infrastructure that's very useful for pipelines and so on. Let's continue to the next feature, and that would be video on terrain. So video on terrain, again, you could publish from TerraExplore, but now you can create it in the GUI of TerraExplore for Web. And actually, and I will talk about it in a bit, everything is also accessible from the API. So I can add this video on terrain object from the API as well. And this is a stream of data, so it can be a video file on your server, it can be a live stream. Let's take this stream that I have over here, go to TerraExplore for Web, go back to my flattened area where I'm planning a new drive-in cinema right on this parking lot, and I will go to the layers, create video on terrain, create 1 and 2 to position it. So this is my projector and where it's being projected onto. I go ahead to the video URL, place it, and then it loads the data. I can, in a minute, I will stop it so the music would not bother us, but I can change different parameters. For example, I can change its altitude like this, and I can change its yaw pitch parameters, and I can pitch it down. So parts of it are on the terrain and parts are not. And this is video on terrain. I will just cancel it so we don't have the noise. So this is video on terrain. Next is point cloud styling. So we said that the CPT information with all its color information is being sent out as 3D tiles databases with batch tables. So for each point, there's actually scalar or attribute information. Sky and Globe Server or TerraExplore for Web allows you to style dynamically. I can configure it in TerraExplore for Web when publishing or use the API to configure it. So for example, this point cloud has the point color from the RGB value, but this layer that I have over here, this layer that I have over here. Let's turn it on, fly to it somewhere else in the world. So see how quickly it goes just somewhere else. And this is point cloud information from a LiDAR scanner. And I actually colored, if I look in TerraXplore Desktop with a project that created it, it's actually defined in a way where based on the number of returns, different colors would be sent. Let me show you classification. So based on the number, the return number in the attribute value, a different color would be applied. And this is how I styled it in TerraXplore Desktop. And then in TerraXplore for Web, I just see the classification or the styling based on the attribute information that is stored inside the CPT, and then the batch table of the 3D tiles. So this is the point cloud styling in TerraXplore for Web. We also have styling and being able to load information for BIM and CAD models. So we take the IFCs or the FBXs, we put them into the efficient 3DML, we publish them to the server, we then consume them in TerraXplore for Web as 3D tiles with batch table, and we can query and style based on it. So let's go back to Tel Aviv. Turn on the BIM layer. Which should be placed somewhere over here. Turn it on, and then I can see the BIM information. Now it doesn't really fit in size, so I can go ahead, open the property sheet. Again, some of the styling can be done directly here, so I will give it a smaller size. Now it's in size 0.4, and I can change with its parameters. I can reposition it to fit, for example, a public view for a proposition for a new building that is supposed to be built. And also, I can see all the BIM information, and then using the analysis and query tool, I can actually get information on different components, including their attribute information coming all the way from your BIM system, from your Revit, or where you created the BIM database. So this is the new support for the batch table, the attribute information within the BIM, and again, or also with major optimizations, performance optimization that were done for these kind of data sets. Shadow and analysis improvements, so the improvements of the shadow quality, and also a nice trick or functionality to make it appear or to be more apparent. So let's go over here to a nice area where we can see the shadow applied, and we go to analysis and we turn shadow on, and the shadow responds to the time in the scene. So as I move, now watch what happens is when I look from further apart based on the my resolution, my computer, and so on, the fidelity or the accuracy of the shadow analysis is 1. And then when I go and zoom in, it improves dynamically. And you can see how accurate it can be, where you can see the little holes in the shadow that comes from the holes in the wall over here. And also what we see here is that there's a setting here for the shadow color. What happens in traditional display like this, that the black shadow is sometimes not very apparent. And it actually is confused sometimes with shadow that came from the original photography that was used to create this mesh. So this functionality to allow you a blue color for the shadow analysis just improves the visibility and the functionality of the shadow, the improved shadow classification or shadow analysis. There's new APIs, so we've extended the APIs for many of the functionalities that TerraXplore adds on top of the Cesium platform. You can get layer information, you can get features from layer, you can create simple objects. There's a drawing API, there are callbacks that were requested, and we really recommend to you to go into a knowledge base in general, to go to a knowledge base. There's a whole section in TerraXplore for Web for developers where you can see description of all the APIs. If you want to see, for example, how to generate an object, it will take you into the detailed API view. And there's also a very nice interactive tutorial where you can go ahead and look at TerraExplore for Web in a sort of like a Fiddle.js or a platform where you can test your code and see, for example, how you can do analysis, start distance. It will give you the code sample for that. It will allow you to run that code. And this code, for example, runs the start tool of the distance tool, and then I can go ahead and do a measurement. So you can take this part into your application, wrap it in your custom GUI and custom functionality, and then execute the TerraExplore for Web functionalities. So for example, I can go with a TerraExplore for Web embedded in a web page in this sandcastle if you want, and I will run it once with no GUI, so it will be just the 3D view, or I can run it again with GUI and then get the controls of TerraExplore. So that was the run without GUI, and if I do again and run it with GUI, I'm resetting each time, so for a development environment, for it to reload the entire thing from scratch. So now I can take, instead of just a 3D window into my custom application, I can take it with the controls, the sidebar, and the analysis. So it's up to you to decide how you want your TerraExplore for Web put into your custom application. You can also take the TerraExplore for Web and add your own tools. So there's code examples here on how to add tools, and take the TerraExplore GUI and supercharge it with your custom tools, your functionalities. So it's any way from taking TerraExplore and adding custom functionalities to it, or taking just a 3D view and putting it into your custom views. And many of our users have already integrated TerraExplore for Web with all its functionalities into their custom mapping tools. We're almost at the end. There's just a small bullet here for Cesium upgrade. First of all, it brings a lot of value to the product. We are moving with, as the Cesium open source is progressing, we take every once in a while the latest version and integrate it in, so you enjoy both the latest and greatest of TerraExplore for Web and the latest and greatest of the Cesium engine. And we also allowed improvements in isolation, which allows people to take TerraExplore for Web as a cut and put into your development resources, and you no longer need to host your application on the same Sky and Globe server. You can host your TerraExplore for Web-based application on another server based on whatever web development strategy and components and frameworks that you use. These are the topics that we wanted to cover. We will take a second to see if there's any questions we can quickly answer, or otherwise we'll resume. Okay, so we did have a few questions during the webinar. They were answered in the panel, but for those of you who were busy listening, we'll quickly review them. There was a question about when using LAS files for point cloud data, and the answer is yes. TerraExplore Pro can take LAZ files, LAS natively. It does convert them as part of the publishing process to CPT, the proprietary or the internal optimized format for point cloud by Skyline, and publish them to Sky and Globe server. There were a few people that were having issues hearing us. So at the end of this, there will be a recording sent to all participants. So if you had any problem, or any of your colleagues had any problem with that, a recording will be sent, and you can also contact us and we will send you if you didn't receive it. Another question was about ECW, and again, the answer is what we started the discussion with, or the webinar with, that you load those ECW files. They are converted and optimized by TerraExplore Pro, the publisher, into an MPT format. There was a question raised there about the size, the conversion ratio. So yes, CCWs are very compressed. They will be essentially recompressed into the MPT, so decompressed and compressed again. The MPT, you can control its compression and its type, whether it's JPEG or PNG, different types of PNGs, and the level of JPEG compression. And then the ECW, as said, will be put into an MPT and published to the server, which can serve those MPTs directly to TerraExplorer or as WMS layers. So that's why we process and convert and optimize. Can ScanGlobe server do WCS? So we weren't clear if this is web coverage server or web catalog service. So ScanGlobe server does not do catalog coverage service. For catalog service, originally we started from that OGC standard, but it didn't really pick up in the industry in the same way by everybody. So there is something catalog service like in the protocol. If you need to be able to query layers and questions and availability of layers from the server, there is a request and response that you can send and get to do those queries. Adding 3D models into TerraExplorer. So you can directly add them to TerraExplorer for web, but you can add them to TerraExplorer Pro again, and then it gets converted into a 3DML and published. There's also support that we didn't discuss here in TerraExplorer for Web 7.3 for GLB models. So more for layers that are instanced, like trees or electricity poles. You can use a point feature layer that points to one or few instance models. When you do them in GLB format, which is equivalent to the 3DS or OBJ, it's a model file for a small model, not a level of resolution textured mesh like a 3DML, then that would get published as GLB into ScanGlobe server and streamed and consumed by the client TerraExplorer for web as a point feature layer that reads all those GLB files. There was some questions about password reset and some other questions that we've directed you either privately or to contact support at skylinesoft.com. We may be able to help with that. There was a question about the transactional approach and whether it can work with shapefiles. So for transactions to be made, one of the supporting formats, which are database in nature, like GeoPackage, SQLite, Oracle, SQL, Postgres, etc., are needed. When TerraExplorer Pro publishes data from your local files into ScanGlobe server, it actually converts them into GeoPackage and publish them as such. So you're already ready for that. No vector styling. There was also a question, or Esri vector styling. There was also a question of whether we can take styling from XML. So it depends on what XML, but this is generally when we would use the TerraExplorer API to read the XML in whatever language or schema it's at, and then use the TerraExplorer API to apply those styling to the layer. And so that's for the Esri styling and so on. We'll see some last minute questions and see if we can respond to them. Otherwise, we would respond directly. We can see who asked which question and get back to you directly. Okay, so web coverage service, that was the answer or clarification from Angel. So there's no support currently for web coverage service. We normally see that the WMS works for us, and it's simple enough, and the clients that support web coverage service are more unique, as said. Okay, and there was a question about, is support for Unreal Engine backward compatible? In other words, will I have to republish existing 3DMLs to the latest version of SGS? So yes, actually, the support for Unreal Engine is based on the 3D tiles standard. So the Unreal client reaches out and expects a 3D tiles, which Terra Explorer or Sky Globe Server, the previous version, also supported, but there were some variations that we needed to adjust so that the flavor of the 3D tiles that is being sent out fits the flavor that Unreal Engine expects. So yes, you need to update your Sky and Globe server to the latest version, and you don't need to redo the 3DML. You may need to clear some caches if you have them from the previous Sky and Globe server version, but you don't need to reprocess the 3DML. Just install the new SGS on top of the previous one, and you're ready for Unreal Engine, which is pretty cool. These were the majority of the questions, and we're a few minutes past our time. We welcome you to go to our knowledge base center, support@skylinesoft.com. There's information about Skyline Globe Server, to Export for Web, and all of our other products. Also, from the knowledge base or from email, support@skylinesoft.com. You can also ask us questions. We'll always know where to pass the more support-oriented questions or business-oriented questions or functionality. One of the questions here was, can I get training from Skyline? So we will be happy to help you with that, and we will direct you to the relevant person within the organization. So with that, we're gonna wrap up, and thank you everybody for the wonderful attendance. Goodbye.